Hello and welcome to the recording of the video that I'm doing for the Machine Learning Foundations for Product Managers exercise 1. In this exercise, we were asked to take CSV file containing give or take 10,000 rows with 4 features on it: temperature, ambient pressure, relative humidity, and vacuum, and one outcome that is the power plant productivity for those given circumstances. So what I did at first, since I don't know anything about energy production, the first thing that I did is look at the data and try to do a little bit of an analysis to try to have the data tell me which ones are the variables that produces a bigger change into the model. So as a first attempt, I took two measures from the highest and lowest energy production days, and this one depicts the higher ones, and we can see that vacuum and sorry and relative humidity kind of like go hand in hand, and temperature and atmospheric pressure go hand in hand in these days, which tells me that maybe one of these couple of features may be relevant, and we could consider just one in case we have a performance issue. At the other end, if we look at the smaller production days in the model, we can see that the vacuum is not really a factor there. We can observe that air temperature and air pressure again go hand in hand. So this is hinting me to believe that the vacuum probably is something that is distorting the model more than giving us the truth. In order to obtain this graphic, I had to play a little bit with the data and take the ambient pressure and divide it by 100 so that I can get a measure that is kind of like in the same order of magnitude as the other ones. So the first thing that I did is I trained the model using all 4 variables, and this is the regression statistics that I got. I went ahead and removed one by one air pressure, relative humidity, vacuum, and temperature. And finally, I removed both air pressure and vacuum and observed the outcome. Okay. So, well, I mean, something that I skip is like for the final validation, I have reserved a subset of all the data that I never used on training the models. So I use this only for the final validation. Now, if we go to see what happened in all the different scenarios and what was the output of it, um, sorry, too many screens for my mouse. So if I look at the summary regression, the original set of data using all the columns yield these kind of results. Is the coefficient is 450, and the multiple R is 0.96. If I look at the results after I remove atmospheric pressure from the formula, I get similar results in multiple R, and I got a slightly higher coefficient by 518. When I remove relative humidity, I obtain 0.95 and 338 as the intercept coefficient. So this is the worst possible feature to be removed, because it seems to be affecting the model. Vacuum seems to yield similar results to the original ones as well. So it could be potentially be used. And removing temperature is one of the most distorting ones. I got this coefficient and multiple R. So finally, doing the exercise with the remaining of the data, I obtained these results, which are pretty much in line with the exercise, and they seem to be slightly better than the exercise using all these 4 features. Um, and I think that's it for the explanation of this course. I hope that you enjoyed the explanation.